All right, so in this video, we're going to talk about molarity, which is a type of concentration. So it's a common way of expressing concentration in chemistry because oftentimes we need to know mole relationships. So we've talked about that before, how we'd change grams into moles so that we could relate one thing to another in an equation. This is the same thing. It's just how many moles do you have dissolved in your solution? How many moles do you have dissolved in a liter of said solution typically? So for molarity, we're going to have an equation that you can use. I don't often think of it as an equation so much as this is just the label, moles per liter, that sometimes is written as a capital M. So capital M means molarity, and lowercase m means molality, which is a completely different thing that we're not going to talk about. But that's why it's actually important that you write out MOL for moles, because other symbols mean different things. So you can't shorten things. You can't use a little m for moles. It has to be MOL at least, right? But otherwise, if I want to make a molar concentration, I essentially place a weight amount into a volumetric flask. I'll show you that in class, and then fill to a certain volume, right? Get that stuff to dissolve first, but then fill to make sure that I had a certain volume that I know, right, that was set beforehand, and then I'll have a concentration that I can work with. The easiest kinds of molarities to make, right? Most of the time, we're going to use 1 molar, 0.1 molar solutions, right? So if I wanted a 1 molar solution of something, so if I wanted a 1 molar solution, I would have to dissolve 1 mole in literally 1 liter, right? So if it was a substance, say salt, and we know that 1 mole of salt has a mass of 58.44 grams, sorry, the pen's kind of freaking out on me, then all I have to do is measure out 58.44 grams and put that amount in 1 liter of water, make it a total volume of 1 liter, and you're going to have a 1 molar solution. It's that simple, right? Because again, if I take 1 mole and I divide it by 1 liter, I'll get a 1 molar solution, right? So if I take 1 mole and place it in 1 liter, and again, 1 mole would be that 58.44 grams that I measured. But if I want a 0.1 molar solution, it works a little bit different, right? I don't want to change the volume here. I'll just change the mole amount to be 0.1 moles. So then instead of weighing out 58.44 grams of salt, I'll just weigh out 5.84 grams of salt, right? So if I want a 1 molar or a 0.1 molar solution, it's typically really, really easy to do, especially considering that substance, whatever it is. Normally in class, we're having to add up the pieces to come up with a molar mass. But if you have the chemical, the substance in front of you in lab, it says right on the bottle, right on the container, the mass of that stuff. 1 mole of this weighs 58.44 grams if it's salt. If it was sodium hydroxide, it would say 1 mole is exactly 40.00 grams for sodium hydroxide, right? So you don't usually have to do much math when you're making a 1 molar or 0.1 molar solution. You just have to decide if you want the decimal where it was originally or 1 to the left, right? And you'll use a 1 liter solution either way because that just makes the math easy, right? Otherwise, we do have an example for molarity that we have to work through, and this is kind of a weird example. Instead of calculating the molarity itself, you have to come up with one of the other 2 pieces. So this one is a little bit weird, right? But this is what you're going to have to do in practice a lot of times. So first thing I want to do in this case, in order to use an equation, period, even if I am going to use the equation, which I won't in my case, I need to have a molarity, which I do have, because molar just means big M, right? So if I see that, I know that 0.50 big M, that's my concentration of my solution. Otherwise, I also need to know moles and liters. Obviously, I'm trying to come up with the liter as an answer, so that should be my X, right? But my mole amount is going to come from my grams given over here. So the first thing that I actually have to do in this case is change my grams into moles. I have to change 21.6 grams of potassium iodide into moles of potassium iodide. So if I look that up on the periodic table, add those pieces together, turns out they have a mass, or that compound has a mass of 166 grams per mole. And it happens to be exactly 166 grams per mole. So I just need a 0 there per 1 mole. And then that would give me an answer when I divide. Again, use a calculator real quick. I'd get an answer of 0.130 moles. So again, I came up with moles because I need moles to possibly plug into my equation over here. That's not what I would typically do. What I'm typically going to do is I'm going to start with that 0.130 moles. And again, molarity is moles per liter. So I can use that as a conversion factor. I prefer to think of this thing up here as not being a big M label, but I'd like that 0.50 to be moles per liter, a complex label, because then I can use it as a conversion factor, because then it means literally 1 liter of that stuff will have 0.50 moles in it. So if I divide by that 0.50, I'll get my answer. In this case, the answer is 0.26 liters, right? And I'm just rounding to sig figs because it says 0.50 for my molarity. So I can only have 2 sig figs in my answer. So that's how I would do it. I would completely understand, though, if you like using an equation, if you wanted to go 0.50 equals some mole amount, which is 0.130, divided by x, and then solve for x in this equation. If you need to, you can put that 0.50 over 1 so you can do a fish method to solve for x. But whatever you like doing is your thing, right? This will also give me the same answer, that my volume is 0.26 liters. So that's how you're going to do molarities.